So I wanted to start going through the problems from the practice. Start off with number one. If you're a monopoly, you've got a demand curve 100 minus 10Q. Marginal cost is 20 per unit. The government's thinking about enacting a price ceiling of 20. That actually makes the problem quite easy because if the price ceiling is equal to 20, you've got marginal cost equal to price. Profits will be 0. So the question is, what's the comparison of that with a single price monopoly setting? So we'll walk through that. So we know revenue will equal P times Q. So that's the same as 100 minus 10Q times Q, or 100Q minus 10Q squared. Marginal revenue is going to equal dq revenue. So that's going to be 100 minus 20Q. You set marginal revenue, which is the 100 minus 20Q, equal to marginal cost of 20. And we're going to solve for Q. 80 is equal to 20Q. Q star is going to be 4. If I want to take that and plug that back in to figure out the price, I know P is equal to 100 minus 10Q, 100 minus 10 times 4, P star is going to equal 60. So the price is 60 minus the cost of 20, because it's constant cost, is going to give me $40 of margin per unit, and 40 times the 4 units is going to give me $160 of profit. So the cost of this regulation to the firm is going to be $160, so the firm would be willing to spend up to that $160. So question 2 is quite similar to question number 1. We're again looking at a monopolist, and part A of the question is basically just solve for the regular monopoly outcome, single price. So we're going to look for, eventually going to set marginal revenue equal to marginal cost. So that means we need marginal revenue. That means we need total revenue. Revenue is equal to P times Q. That means that we're going to have to figure out the inverse demand function. This is the same as saying 2P is equal to 640 minus Q. Divide through by 2. That gives us our inverse demand function. So now I can plug that into my revenue equation. P is equal to 320 minus 1/2 Q multiplied by Q. That's going to give me 320 Q minus 1/2 Q squared. Marginal revenue is equal to dq revenue. So 320Q gives me 320. Minus 1/2 Q squared gives me minus Q. So now I've solved for my marginal revenue. Next thing I need to do is do marginal cost. I'm going to go up here to my total cost function and take the derivative of it. dq total cost is going to equal, the 100 goes away and I'm left with 4Q. Set marginal cost equal to marginal revenue. Marginal cost is equal to 4Q. Set that equal to marginal revenue, which is 320 minus Q. Now just solve. That's the same as 5Q is equal to 320. Q star is going to equal 320 by 5, or 64. To figure out P star, I can just go back to the inverse demand function that I solved before. So that's up here. My P star is going to equal 320 minus 1/2. I know what my Q is. It's 64. So that's going to give me P star is equal to 288. Last thing we were asked to do is figure out the profits. So profit is going to equal revenue minus total cost. Revenue is P star times Q star. P star is 288. Q star is 64. Total cost function, go back up and look at it again. 100 plus 2Q squared. 100 plus 2, my optimal Q is 64 squared. So your profit is 10,140. So that solves part A. So part B is just going to look for a very small change. It says your fixed cost is going to go up by 610. Bring your total fixed cost up to 710. And the question is, would there be any change to production? There's no change because this won't affect your marginal cost. It's not going to affect your marginal revenue. And in part A, we just set marginal revenue equal to marginal cost, so this is going to show up. So no change. For part C, the question is, do you prefer that lump sum tax, or do you want to re-optimize under a variable cost of $10 per tractor? So it's a production cost. We're not going to have to run through the price formula, but we'll have to change our marginal cost equation to reflect that, right? Marginal revenue is going to be unchanged. Total cost is now going to equal 100, same as before, plus 2Q squared, same as before, plus 10Q. That's our new tax. Marginal cost equals D, DQ, total cost. So it's going to leave me with 4Q plus 10. That's new compared to the earlier equation. So I'm still going to set marginal revenue, which was equal to 320 minus Q. Set that equal to the new marginal cost, which is 4Q plus 10. That leaves me with 5Q is equal to 310. The new Q star is going to equal 62. That's down from the earlier 64. For our P star, we plug it back into P is equal to 320 minus 1/2 of Q. Q is 62. So our P star under this new setting is going to be 289. The last thing we have to do is figure out what the profits will be. Profit will equal revenue minus total cost. Our revenue is P times Q, so that's 289 times 62 minus, and now we have to grab our new total cost function. New total cost function is 100 plus 2 times 62 squared plus the production tax of 10Q. Again, Q is 62. So profit is going to equal under this 9, 5, 10. If we scoot way, way up to our earlier profit was 10,140. Profit on a flat tax is going to equal the profit old, 10,140, minus the flat tax of 610. So our profit under the flat tax is 9,530. So which regime do you prefer? Flat tax leaves you a little bit ahead.